minimum clearance between rigid metal conduit and a steam pipe running parallel to it is 6 inches. This clearance is crucial for several reasons, primarily related to safety and the operational integrity of both the electrical and steam systems. Firstly, the heat emitted by the steam pipe can significantly affect the temperature of the rigid metal conduit and the conductors within it. Excessive heat can degrade the insulation of the wires, leading to potential short circuits, ground faults, and even electrical fires. The 6-inch clearance helps to mitigate this thermal impact by providing sufficient airspace for heat dissipation. Secondly, maintaining this clearance allows for adequate access for maintenance and repairs of both the conduit and the steam pipe. If the conduit is too close to the steam pipe, it can be difficult to inspect, repair, or replace either component without disrupting the other. This accessibility is essential for ensuring the long-term reliability and safety of both systems. Thirdly, the National Electrical Code (NEC) provides guidelines and requirements for the installation of electrical systems, including clearances from heat sources. While the NEC doesn't explicitly state the 6-inch clearance for steam pipes in every situation, it does emphasize the need to protect electrical conductors from overheating and to ensure safe working clearances around electrical equipment. Local codes and regulations may also specify this clearance requirement to ensure compliance with industry best practices and safety standards. When installing rigid metal conduit near steam pipes, several factors must be considered to ensure that the 6-inch clearance is properly maintained. These include, firstly, proper planning and layout. Before starting the installation, carefully plan the routing of the conduit and the steam pipe to ensure that they will not interfere with each other and that the required clearance can be maintained throughout their entire length. Secondly, using appropriate support structures. Use suitable hangers, clamps, or supports to securely mount the conduit and the steam pipe, maintaining the 6-inch clearance. Ensure that these supports are strong enough to withstand the weight of the conduit, the steam pipe, and any additional loads, such as ice or snow. Thirdly, considering thermal expansion. Steam pipes are subject to thermal expansion and contraction as their temperature changes. Ensure that the conduit and its supports are installed in a way that allows for this movement without compromising the 6-inch clearance or putting undue stress on the conduit or the steam pipe. Fourthly, implementing proper insulation. Consider insulating the steam pipe to reduce the amount of heat radiated towards the conduit. This can help to further protect the electrical conductors from overheating and reduce the risk of insulation degradation. Fifthly, conducting thorough inspections. After the installation is complete, conduct a thorough inspection to verify that the 6-inch clearance is maintained throughout the entire length of the conduit and the steam pipe. Also, check that all supports are securely fastened and that there are no signs of stress or damage to the conduit or the steam pipe. To further elaborate on the importance of each of these factors, let's delve into more detail. Proper planning and layout involves creating detailed drawings or schematics that show the exact routing of the conduit and the steam pipe. These drawings should indicate the location of all supports, bends, and junctions, as well as the required clearances. Before finalizing the plan, it's essential to consult with qualified engineers or electricians to ensure that it complies with all applicable codes and regulations. When selecting support structures, it's important to consider the specific requirements of the conduit and the steam pipe. For rigid metal conduit, use hangers or clamps that are specifically designed for this type of conduit. These supports should be made of corrosion-resistant materials to withstand the harsh environment often found in industrial or commercial settings. For steam pipes, use supports that are designed to accommodate thermal expansion and contraction. These supports may include rollers, springs, or other flexible elements that allow the pipe to move without putting stress on the supports or the surrounding structures. Thermal expansion is a critical factor to consider when installing steam pipes. As the temperature of the steam increases, the pipe will expand in length. This expansion can be significant, especially for long runs of pipe. If the conduit is installed too close to the steam pipe, the expansion can cause the pipe to come into contact with the conduit, potentially damaging both components. To accommodate thermal expansion, the conduit and its support should be installed in a way that allows for movement. This may involve using expansion joints in the conduit run or providing flexible connections at the points where the conduit is supported. Insulation is another important consideration when installing steam pipes near electrical conduit. Insulation helps to reduce the amount of heat radiated from the pipe, which can help to protect the electrical conductors from overheating. There are many different types of insulation available, each with its own advantages and disadvantages. The type of insulation selected should be based on the specific requirements of the application, including the temperature of the steam, the ambient temperature, and the desired level of heat reduction. Conducting thorough inspections is essential to ensure that the installation is safe and compliant with all applicable codes and regulations. The inspection should be performed by a qualified electrician or engineer who is familiar with the requirements for installing electrical conduit near steam pipes. During the inspection, the electrician should verify that the 6-inch clearance is maintained throughout the entire length of the conduit and the steam pipe. They should also check that all supports are securely fastened and that there are no signs of stress or damage to the conduit or the steam pipe. In addition to these factors, it's also important to consider the potential for condensation. Steam pipes can produce condensation, which can drip onto the conduit and cause corrosion. To prevent this, the conduit should be installed in a way that allows for drainage of any condensation. This may involve sloping the conduit slightly or providing weep holes at low points in the run. Furthermore, it's important to ensure that the conduit is properly grounded. Grounding helps to protect against electrical shock and can also help to prevent damage to electrical equipment. The grounding system should be installed in accordance with the National Electrical Code and all other applicable codes and regulations. In summary, maintaining a 6-inch clearance between rigid metal conduit and steam pipes running parallel is essential for safety, code compliance, and the long-term reliability of both systems. By carefully planning the installation, using appropriate support structures, considering thermal expansion, implementing proper insulation, and conducting thorough inspections, you can ensure that the installation is safe, compliant, and will provide years of reliable service. The consequences of not adhering to the 6-inch clearance can be severe, including electrical fires, equipment damage, and potential injury or death. It is therefore imperative that all electrical installations near steam pipes are performed by qualified professionals who are familiar with the applicable codes and regulations. Moreover, it's worth noting that the specific requirements for clearances may vary depending on local codes and regulations. It's always best to consult with local authorities or a qualified electrician to ensure that the installation complies with all applicable requirements. For example, some jurisdictions may require a larger clearance than 6 inches, while others may have additional requirements for grounding, bonding, or insulation. In addition to the physical clearance, it's also important to consider the environmental conditions in the area where the conduit and steam pipe are installed. For example, if the area is subject to high humidity or corrosive chemicals, it may be necessary to use special types of conduit or insulation to protect against corrosion. Similarly, if the area is subject to extreme temperatures, it may be necessary to use conduit and insulation that are rated for those temperatures. Another important consideration is the type of steam being transported by the pipe. Different types of steam have different temperatures and pressures, which can affect the amount of heat radiated from the pipe. For example, high-pressure steam will radiate more heat than low-pressure steam. Therefore, it's important to select conduit and insulation that are appropriate for the type of steam being transported. Furthermore, it's crucial to document the installation properly. This documentation should include detailed drawings or schematics showing the exact routing of the conduit and the steam pipe, as well as the location of all supports, bends, and junctions. The documentation should also include a list of all materials used in the installation, including the type of conduit, insulation, and supports. This documentation will be invaluable for future maintenance, repairs, or modifications to the electrical or steam systems. In addition to the 6-inch clearance, it's also important to maintain adequate clearance around other electrical equipment, such as junction boxes, transformers, and switchgear. These clearances are specified in the National Electrical Code and are designed to ensure safe working clearances for electricians and other qualified personnel. Finally, it's essential to remember that electrical safety is everyone's responsibility. If you see something that doesn't look right, don't hesitate to report it to a qualified electrician or your supervisor. By working together, we can create a safe and compliant electrical environment for everyone. Continuing on the topic, let's delve deeper into the specific types of rigid metal conduit and their applications in proximity to steam pipes. Rigid metal conduit, or RMC, is a heavy-duty electrical raceway often made of galvanized steel or aluminum. Its robust construction provides excellent protection for conductors against physical damage, moisture, and corrosive environments. When installing RMC near steam pipes, it's crucial to select the appropriate type and ensure it's properly installed to maintain the required clearance and prevent potential hazards. Firstly, galvanized steel RMC is a common choice for many electrical installations due to its strength and resistance to corrosion. However, when used near steam pipes, the galvanization can be affected by the heat, potentially leading to premature corrosion. Therefore, it's essential to inspect galvanized steel RMC regularly for signs of corrosion and to take appropriate measures to protect it, such as applying a protective coating. Secondly, aluminum RMC is another option that offers excellent corrosion resistance and is lighter than steel, making it easier to install. Aluminum RMC is particularly suitable for applications where weight is a concern or where the conduit is exposed to corrosive environments. However, aluminum RMC is more expensive than steel RMC and may not be as strong in certain applications. Thirdly, stainless steel RMC provides the highest level of corrosion resistance and is ideal for use in harsh environments where other types of conduit may corrode quickly. Stainless steel RMC is commonly used in food processing plants, chemical plants, and other industrial facilities where corrosive substances are present. However, stainless steel RMC is the most expensive option and may not be necessary for all applications. When installing RMC near steam pipes, it's also important to consider the type of fittings used. Fittings are used to connect sections of conduits and to provide access points for wiring. The fittings should be made of the same material as the conduit to prevent galvanic corrosion. Additionally, the fittings should be properly sealed to prevent moisture from entering the conduit. Furthermore, the support system for the RMC should be designed to withstand the weight of the conduit and the conductors, as well as any additional loads such as ice or snow. The support should be spaced at appropriate intervals to prevent the conduit from sagging or bending. The support should also be securely attached to the building structure to prevent them from coming loose. In addition to the physical installation of the RMC, it's also important to consider the electrical grounding of the conduit. The RMC should be properly grounded to provide a path for fault current to flow back to the source, which helps to protect against electrical shock and prevent damage to equipment. The grounding system should be installed in accordance with the National Electrical Code and all other applicable codes and regulations. Finally, it's essential to document the installation properly. This documentation should include detailed drawings or schematics showing the exact routing of the conduit and the steam pipe, as well as the location of all supports, vents, and junctions. The documentation should also include a list of all materials used in the installation, including the type of conduit, insulation, and support. This documentation will be invaluable for future maintenance, repairs, or modifications to the electrical or steam systems. In conclusion, installing rigid metal conduit near steam pipes requires careful planning, selection of appropriate materials, and adherence to all applicable codes and regulations. By following these guidelines, you can ensure that the installation is safe, compliant, and will provide years of reliable service. Now, let's consider a practical example to illustrate the importance of maintaining the 6-inch clearance. Imagine a scenario where a rigid metal conduit is installed too close to a steam pipe in a manufacturing facility. Over time, the heat from the steam pipe causes the insulation on the wires inside the conduit to degrade. Eventually, the insulation cracks and crumbles, exposing the bare conductors. One day, a worker accidentally brushes against the conduit, and because the conduit is not properly grounded, they receive a severe electrical shock. This incident could have been prevented if the 6-inch clearance had been maintained and the conduit had been properly grounded. This example highlights the critical importance of following all applicable codes and regulations when installing electrical conduit near steam pipes. Failure to do so can have serious consequences, including electrical shock, equipment damage, and even death. Therefore, it's essential to take all necessary precautions to ensure that the installation is safe and compliant. Let's also think about some advanced techniques to help maintain the clearance. One advanced technique involves using thermal imaging to monitor the temperature of the conduit and the steam pipe. Thermal imaging can detect hot spots or areas where the insulation is failing. This information can be used to identify potential problems before they become serious. Another advanced technique involves using wireless sensors to monitor the clearance between the conduit and the steam pipe. These sensors can send alerts if the clearance is reduced due to thermal expansion or other factors. This allows for proactive maintenance and prevents potential problems from occurring. These advanced techniques can help to improve the safety and reliability of electrical installations near steam pipes. However, it's important to note that these techniques are not a substitute for proper planning, installation, and maintenance. They should be used as a supplement to these traditional methods. In summary, maintaining the 6-inch clearance between rigid metal conduit and steam pipes is a critical safety requirement. By following all applicable codes and regulations, using appropriate materials, and implementing advanced monitoring techniques, you can ensure that the installation is safe, compliant, and will provide years of reliable service. The safety of workers and the reliability of equipment depend on it.